Download this code from codegive.com, link in the description below. Accept encoding HTTP header, a deep dive. The accept encoding HTTP request header is a crucial tool for optimizing web performance by allowing clients, browsers, applications, etc., to inform servers about the compression algorithms they support. This enables the server to compress the response body before sending it, reducing the amount of data transmitted and improving the user experience. This tutorial will provide a comprehensive understanding of the accept encoding header, covering its syntax, common encoding algorithms, server-side implementation, client-side considerations, security implications, and more. 1. Understanding the basics. Purpose The accept encoding header informs the server about the compression algorithms the client is willing to accept for the response body. Syntax The header consists of one or more encoding tokens, each optionally followed by a quality value. Structure accept encoding, encoding token, Q equals value, encoding token, Q equals value. 2. Components explained. Encoding token This is the name of a supported compression algorithm. Common examples include zip, gzip compression. The most widely supported and recommended compression algorithm. Deflate, deflate compression. Less common than gzip, but still supported by many browsers and servers. Often uses the zlib format, which can be slightly different from raw deflate. Br.ly compression. A modern compression algorithm that generally offers better compression ratios than gzip. Increasingly well supported. Compress, Lempelziv-Welch, LZW, compression. Older algorithm, now rarely used due to patent issues. Generally discouraged. Identity, no compression. Indicates that the client will accept the response without any compression. Wildcard. Indicates that the client accepts any encoding algorithm. Use with caution. Q equals value, quality value, a decimal number between 0 and 1, inclusive, that indicates the client's preference for a particular encoding. 1, or omitted highest preference. The default value if Q is not specified. 0, indicates that the client refuses to accept the specified encoding. Values between 0 and 1, represent intermediate levels of preference. A higher value indicates a stronger preference. Order of preference The server should choose the most preferred encoding algorithm based on the Q values and the order in which the encoding tokens appear in the header. If two encodings have the same Q value, the one that appears earlier in the header has higher precedence. 3. Examples of accept encoding headers. Example 1, basic preference for gzip and deflate. This indicates that the client prefers gzip compression, followed by deflate compression. The server should choose gzip if possible. Example 2, specific preference with quality values. This indicates the following preference order. 1 gzip, Q equals 0.9. 2 deflate, Q equals 0.8. 3.ly, Q equals 0.5. The server should select the best encoding available based on this order and its own capabilities. Example 3, rejecting deflate. This indicates that the client accepts gzip compression but explicitly refuses to accept deflate compression. The server should not send a deflate encoded response. Example 4, accepting any encoding, use with caution. This indicates that the client will accept any encoding algorithm the server supports. While seemingly convenient, using asterisk can lead to unexpected behavior if the server supports an algorithm that the client handles poorly. It's generally best to explicitly list the supported algorithms. Asterisk example 5, accepting.ly and gzip. This indicates a preference for .ly followed by gzip, with gzip having a lower quality rating. 4. Server-side implementation, code examples. Here are examples of how to implement server-side response compression based on the accept encoding header in different programming languages. A. Python, using Flask. Explanation asterisk. 1. Import necessary modules asterisk zip, slib, .ly, io, Flask, request, make underscore response. You might need to install .ly using pip install .ly. 2. Get accept encoding asterisk. The code retrieves the value of the accept encoding header from the request. 3. Check for supported encodings asterisk. It checks if the header contains gzip, deflate, or br.ly. 4. Compress and set headers asterisk. If a supported encoding is found, the response body is compressed using the corresponding algorithm, gzip.compress, zlib.compress, or .ly.compress. The content encoding header is set to indicate the compression algorithm used. The compressed content is set as the response data. 5. Send uncompressed content asterisk. If no supported encoding is found, the response is sent without compression. 6. Error handling, .ly. It includes a try, except block to handle potential .ly.error exceptions if the .ly library is not installed or if there are issues with .ly compression. B. Node.js, using Express. Explanation asterisk. 1. Import modules asterisk Express, zlib. For modern Node.js versions, zlib includes .ly. For older versions, you might need npm install @gfx/zlib and then const.ly equals require @gfx/zlib. 2. Get accept encoding asterisk. The code retrieves the value of the accept encoding header from the request. 3. Check for supported encodings asterisk. It checks if the header includes br, zip, or deflate. 4. Compress and send asterisk. If a supported encoding is found, the response body is compressed using zlib.ly compress, zlib.gzip, or zlib.deflate. The content encoding header is set to indicate the compression algorithm used. The compressed buffer is sent as the response. 5. Error handling asterisk. The code includes error handling for the compression functions. If an error occurs during compression, it falls back to sending the uncompressed content. 6. Send uncompressed content asterisk. If no supported encoding is found, the response is sent without compression. C. Java, using Spring Boot. Explanation asterisk. 1. Imports asterisk. Imports the necessary Spring Boot classes and Java I/O and compression classes. 2. @request header asterisk. The @request header annotation is used to extract the value of the accept encoding header from the request. 3. Check for supported encodings asterisk. The code checks if the accept encoding header contains gzip or deflate. .ly support would require additional libraries. 4. Compress and return asterisk. If a supported encoding is found, the response body is compressed using gzip output stream or deflator output stream. The content encoding header is set to indicate the compression algorithm used. A response entity is returned with the compressed data and the appropriate headers. Note the use of standard charsets.iso_8859_1 when creating the string from the byte array. This is because the compressed data is binary and should not be interpreted as UTF-8. 5. Send uncompressed content asterisk. If no supported encoding is found, a response entity is returned with the uncompressed content. Important considerations for server-side implementation ****. Content type ** compression is most effective for text-based content, HTML, CSS, JavaScript, JSON, XML, etc. Avoid compressing already compressed content, images, videos, audio files. Dynamic versus static content For static content, pre-compressing files during deployment is often more efficient than compressing them on each request. Caching Make sure that caches are configured to correctly handle compressed content. Use the vary, accept-encoding header to indicate that different versions of the resource may exist for different accept-encoding values. Performance compression takes processing time. Choose a compression level that balances compression ratio and CPU usage. *.li support *.li generally offers better compression ratios than gzip, but it may not be supported by all clients. Consider using .li as the preferred option and falling back to gzip if .li is not supported. Prioritization Implement proper prioritization based on the quality values in the accept-encoding header. Security Be cautious about compressing responses based solely on the accept-encoding header from untrusted clients, as this could potentially be exploited in some scenarios. Input validation is always important. 5. Client-side considerations. Browser support Most modern browsers automatically include the accept-encoding header in their HTTP requests. You typically don't need to explicitly set it in the browser's configuration. JavaScript When making requests using JavaScript, example using fetch or XML HTTP request, the browser automatically handles the accept-encoding header. Other clients When building other types of HTTP clients, example mobile apps, command line tools, you should explicitly set the accept-encoding header to indicate the compression algorithms your client supports. Testing Use browser developer tools, network tab, or command line tools like curl to inspect the accept-encoding header being sent by your client. Mobile applications Compression is particularly important for mobile applications, where bandwidth can be limited and latency can be high. 6. Using curl to test accept-encoding. Curl is a powerful command line tool for making HTTP requests and inspecting headers. Here's how you can use it to test the accept-encoding header. Basic request, let curl handle the encoding. The verbose flag will show the request and response headers. Curl typically includes a default accept-encoding header. Specify accept-encoding This explicitly sets the accept-encoding header to accept gzip, deflate, and .li compression. Check the response headers Look for the content encoding header in the response to see which compression algorithm, if any, the server used. No compression This tells the server that the client only accepts the identity encoding, no compression. Wildcard, use with caution. This tells the server to use any encoding it supports. 7. Security considerations. While generally safe, there are some potential security considerations related to the accept-encoding header. Compression ratio side-channel attacks, example crime, breach. These attacks exploit the fact that the size of a compressed response can reveal information about the uncompressed content. They are less of a concern with modern TLS, HTTPS, configurations, but it's important to be aware of them. Ensure you are using strong encryption and are keeping your TLS libraries up to date. Denial of service, DOS, Attacks **. A malicious client could send a large number of requests with an accept encoding header that forces the server to use a computationally expensive compression algorithm, potentially overloading the server. Input validation, rate limiting, and proper resource management can help mitigate this risk. Vary header handling. If your server uses different compression algorithms for different requests, ensure that the vary, accept encoding header is set correctly. Incorrectly caching compressed responses can lead to security vulnerabilities. 8. Conclusion. The accept encoding HTTP header is a valuable tool for optimizing web performance by enabling response compression. By understanding its syntax, common encoding algorithms, and server-side implementation, you can significantly reduce the amount of data transmitted between the server and the client, leading to faster page load times and a better user experience. Remember to consider the various factors outlined in this tutorial, including client support, server-side performance, caching, and security, to ensure that you are using accept encoding effectively and safely. Properly implemented, it can dramatically improve the efficiency of your web applications.